Good morning, good afternoon, and good evening, wherever you may be in the world. We are in question 2 of our paper 2 final exam preparation series. Thank you for tuning in. So let us take a look at the first one. There you go. All right, so we are given a parallelogram. Okay, so we'll never be given properties of quads or triangles. You will need to know the properties of the individual, quads or triangles. Now, those properties is what you need to indicate on the diagram itself that is given. Parallelogram, we know that opposite sides are parallel. Not only that, but they are also equal. Okay, so if that is 8, that will be 8 units. Okay, and we are given a magnitude here of the angle to be 55 degrees. Okay, if you want, you can talk about alternate angles and link it to that one and say that is also 55 degrees. Okay, what are we asked to calculate? This angle here, ADC, or just angle D. Okay, how can we do that? We know that the sine rule can come in handy here because compares the angle with its opposite side. Okay, and here we have an angle with its opposite side, so that is taken care of. And sine 55 degrees over 8. Okay, and therefore cross multiply or multiply both sides by 5. We take our calculator. We have 5 times sine of 55 divided by 8. That gives us 0.51197. It continues. Okay, and therefore angle ADC, sine inverse, we get 30.8 degrees, correct to 1 decimal place. All right, so it was pretty much straightforward. Properties of parallelogram applied correctly, and of course using the sine rule. Good, let us go to question 2. Have a look. All right, so in this question we ask to calculate the area of the parallelogram ABCD. We got the magnitude of that angle is 30.8. That was given as 55. Can we get this one? Yes, 180 minus this 2 gives you 94.2 degrees. Okay, now what do we need to apply? The area rule, because we're looking for area. So we have a side, angle, side. That relationship is ideal for the area rule to apply. Good stuff. So area of triangle ACB is equal to half times 5 times 8 times sine of angle 94.2 degrees. Okay, what do we take? Our calculators and plug in the numbers. This gives us 19.946 units square, and therefore the area of the palm ABCD will be 2 times this number here. Okay, giving us 39.9 units square. Good, straightforward, no problems detected there. Just needed to move carefully and correctly. Okay, good stuff. We are now heading off to the next question. Have a look. Right, so in this question we are interacting with trigonometry, and it is basic trig really, because we have a ratio here with a restriction, which means we need to choose the correct quadrant out of the 4 quadrants that we have. Okay, so let's write this in standard format. It's 5 over 13, and the restriction is 180 to 360 degrees for the angle theta here, and theta, cos being positive, means that we're in quadrant what? Is it 3 or 4? Because 180 degrees is here, this is 270, and that is 360. So between these 2 quadrants, when you go anti-clockwise, where is cos of an angle positive, it's definitely in there, in quadrant 4. Okay, so your theta is definitely between 180 degrees and theta. And 360 degrees. Okay. Now, how do we use these numbers in the right angle triangle that we've drawn here? We know that 13 is the hypotenuse and the 5 is the adjacent, or the magnitude of the x variable there. What do we need? The value of y, or the opposite side of the right angle triangle. What do we need to do? We need to get it by theorem of Pythagoras, 13 square minus 5 square, giving us negative 12. Okay, so that will be a negative 12, because obviously the y values below the x-axis are negative. So the value of sine theta will be opposite over hypotenuse. And that is it. That is the answer to the question. Great stuff. Let us move on to the second one. Okay, now we are asked to find the value of cos theta plus 45 degrees. It's a clear observation that we make now is a compound angle identity that we'll need to call in, and obviously expand it correctly in terms of its of that identity. Okay, so this is equal to cos theta cos 45 degrees minus sine theta and sine of 45 degrees. Okay, we are told we need to do this without the use of a calculator. So, being good students, we are going to follow the instruction. Okay, good. Cos of theta, that comes from the question itself. We multiply this by cos of 45 degrees is 1 over root 2 minus sine theta. Did we get in the previous question? Yes, negative 12 over 13, and then we have 1 over root 2 here. Good, so let us multiply the fractions. We have 5 over 13 root 2, okay, a double negative there, plus 12 over 13 root 2. Denominators are the same, we can add the numerators. So this becomes 17 over 13 root 2. Okay, you can leave your answer there, or you can rationalize it to have your set in the numerator. But yeah, this takes care of this question. All right, and now we are done with question 2, and that was a bit of trick, a bit of analytical geometry, and let us see what the next question, which is question 3, has in store. Okay, see you in the next video. Thank you for tuning in. Shap shap.